Hello and welcome to another Deva tutorial. Today, we will explain how to tune the axis on a Deva 030 servo amplifier with a DCE drive, a DC brushed motor with tacho feedback, and a Deva 004 motion controller. Firstly, each axis you are tuning needs to have its pitch and count set so that the axis position feedback device is counting in the correct units and direction. Next, ensure switch 2 is set to left, enabling tacho feedback. Also ensure current mode is off. Then, we need to check that the tacho feedback is phased correctly as described in the 030 user guide, under Tacho Feedback. Open the Axis Tuner utility program. Use the force buttons to apply a short pulse of voltage. If the motor progressively spins faster, that indicates the voltage from the tacho is the incorrect phase, and you will need to switch around the connections to the motor. The first 030 potentiometer to adjust is the loop gain. This affects how aggressively the axis reacts to changes in voltage. To adjust the loop gain or another value, turn the respective potentiometer. To test the loop gain, you can use the force button with a moderate value, for example, 10% of the maximum voltage. Then you can observe the graph to see how the current loop gain affects the speed changes. The axis is undamped if the graph has an unstable speed with continuous under and overshoots. It is underdamped if the graph has some overshoots. It is critically damped if the graph has no overshoot and a slight curve. It is overdamped if the graph has no overshoot and a large curve. The ideal loop gain depends on the type of machine and the user's needs. If in doubt, start between critically and underdamped. The second 030 potentiometer we can adjust is the tacho gain. This affects the voltage to speed scale. It should be adjusted so that the required motor speed is achieved for a given voltage. Using the force button with 10% of the maximum voltage, you should get 10% of your desired maximum speed. Adjust the tacho gain until the speed matches. If the tacho feedback for the motor is very low, when the axis is at maximum speed, the low tacho option can be enabled by switching the switch to on. A tacho signal is considered to be low when 5 volts or less are produced at the maximum axis speed. The third 030 potentiometer we can adjust is the offset. This allows the axis to be stationary when the voltage input is 0. Using the force button with a 0 value, adjust the offset until the speed is 0. The fourth 030 potentiometer is the maximum current, I maximum. This will be set later in the process. Now, we can set the maximum speed and voltage for the axis using the config editor. Ensure they are set to values reflecting the scale you decided when adjusting the tacho gain. This will allow us to return to the tacho gain and offset, and apply more precise tuning using the scale at the top of the axis tuner and the axis lag value. For the tacho gain potentiometer, observe the scale meter while running a closed loop cycle and check that the meter is around 1. For the offset potentiometer, observe the lag display while running a closed loop with the axis stationary, and check that the lag is around 0. We can now adjust the proportional gain, kV, derivative gain, kd, and integral gain, ki, for the axis using the config editor. The kV is proportional to the error between the model and the axis position. The higher the kV, the larger the voltage will be applied to the drive. Experiment with adjusting this value with the help of the axis tuner until it delivers the performance you desire. If you cannot find an adequate performance with kV alone, you can also adjust the kd value, which can help stabilize the axis. Ki is only activated when the axis is stationary and is used to improve the steady-state performance of the control system in the presence of disturbances such as friction, offset drift, and gravity. For more information on KD and Ki, please consult the Deva 004 user guide. Finally, once the axis is moving appropriately, configure the axis tuner to make a move at full speed for the entire distance of the machine. While it is cycling, we can reduce the current limit to the required level. It is used to limit the maximum current delivered to the motor. Adjust the I-max potentiometer until the fault LED flashes. This indicates it is hitting around 80% of the configured limit. This completes the configuration. Thanks for listening to this Deva tutorial. If you have any questions or problems, please consult the Deva manuals for a more in-depth explanation or email support@deva.co.uk.